Minasan, konnichiwa. Zamurai Engineer desu. So in this video live streaming, we will continue our discussion on different types of areas and express and explain some of the important consideration about this concept, and we will show it by use of examples. So example from our textbook, from McCormack and Chernak. So before we go further, I would like to ask if our sound is clear. Sound check. Okay, so it's clear enough. So after a while, I would like to remind our checker to take the attendance 8 minutes later. Okay, so let us proceed with the problem number 4, example number 4, that would show us how to use the principle we have just learned. Okay. So problem number 4 states that we have a given figure of cross section and side view. It is a what? W type section, particularly W12 by 16. So what do we mean by that? W12 meaning 12 is the nominal depth of the section, 16 is the weight, okay, meaning pounds per feet. Okay, so we are asked to determine the area, the net area, okay, of this section, considering that there are 1-inch bolts, okay, that have to be used. Therefore, there are provision for holes, and as you can see on the figure, there are 3 holes. Okay, so there are 3 holes. What would be the net area of this section? So again, we are very interested on the net area or the area, because areas, the greater the areas, the greater the resistance of the material to failure, okay, or the greater the resistance of the material to withstand the load. Okay? Therefore, we would like, if we could be allowed to do so, we have to use maximum, okay, cross section if that's possible, economically and other reasons. Okay, so however, since we are limited with the current question at hand, we are given W12 by 16, and if you take a look at the table, the gross area, the gross cross-sectional area of this specific section W12 by 16, you will find out. Use your textbook, use your table. Use your table of what? AISC 360, or use your table NSCP. Okay, you can use them so that you can find out, you can verify that the area is actually 4.71 square inch. So please verify that we have that particular value. So Okay. So let's get back. We have the specific location of holes. As you can see, 3 inches from the edge or the top flange, going down 3 inches to the center of the first hole, another 3 inches to the next hole, and another 3 inches to the next hole. So there are 3 holes and another 3 inches to the bottom exterior surface of the flange. Okay, so that's why the total depth is 12 inch. Okay, 12 inches. Okay, and the width of the web or the thickness of the web, okay, here is given on the figure is equal to 0.22 inch. 0.22. If it is not given on the picture or given data, you have to use the table. That is how we have to solve the problem in steel design. Mainly, we are looking at the table, okay, in order to get all the necessary given values. In problem solving, up to the board exam, up to your actual future career. If you encounter steel design, you have to prepare your table. Okay, NSCP, AISC. Not anybody's table, but those tables that are shown on the codes. Okay, so you can gather also that information. Okay, 0.22, the thickness of the web, then gross sectional area is 4.71. And not only that, we have the distance, okay, I think lateral distance from a hole, vertical alignment of holes, BD, as you can see, has a distance 2 inches. Okay, has a distance 2 inches to the hole letter C. Okay, okay, I don't know what it is, but there is another as you can see here, I don't know why there is another 2 inches. It is not necessary. There is no hole or something in this part. So this is about excessive use of dimension. Dimension for what? This is dimension for what? Nothing. Okay? So we only need 2 inches here in order to clarify that the lateral distance between this center of holes is 2 inches. Okay? What is the next 2 inches? There's nothing about it. Okay? So unlike this one, all of these are required. Okay? So also we are given the width of the flange. Okay? The flange width. Okay? And if it is not given, you can also find it from the table. You can also find it from the table. Okay? So this one, and this one. So you can all find those from the table. Now, so since we are going to determine the net area, let us find the net area. Solution. First, we need to open your textbook. Okay? I will explain it line by line, but it is provided on the textbook that we are using. Okay? So net area, hole diameter is 1 inch plus what? Plus 1/8 inch. So from the code, it is 1 over 16 to 1 over 8. And this author is using 1 over 8 as a clearance. Okay? So that is for what? For the normal operation of making a hole. So making a hole for a 1 inch diameter bolt. So you need 1 over 8 inch clearance due to the practical necessity. Okay? Practical necessity of this. Okay? We already explained that. Why it is necessary. Okay? There's a reason. There's a specific reason we already mentioned. Okay? So okay. So now let us perform the path. There are only two paths. Okay? There are only two paths wherein okay, there are only two paths wherein we can expect some degree of risk, okay, for element failure. That is path A, B, D, E. And another one is A, B, C, D, E. Those are the two possibilities. Of course, we cannot expect this section to fail here, because they have greater amount of cross-sectional area. So the greater amount of cross-sectional area in this region, in those parts, we can expect failure on those parts. So the lesser amount of area, that is the weakest link. So this is maybe the weakest link, or this may be the weakest link. So there are only two. So let us start with A, B, D, E. That is the reason why we are taking a look at these two paths, because we want to predict at which path this section will fail. So A, B, D, E. Oh, A, B, D, E. Straightforward. Cross-sectional area minus the two holes. Straightforward because it is vertically straight. Okay? There is no staggered holes in this path, A, B, D, E. Okay? So straightforward. Cross-sectional area is exactly 4.71 as given, as we can get from the table, okay, for W12 by 16, minus two holes. Okay, there are two holes here, B and D holes. Therefore, you need two here. You need to put two, and then what is this? This is the diameter of the hole. This diameter of the hole. The diameter of the bolt is 1 inch plus 1/8 inch, 1 and 1/8 inch. Okay, 1 and 1/8 inches. Okay, times the thickness. So the diameter times the thickness, that is the area. That is the area of projection of the hole. Okay, along this path. That is the projection of the whole area. Okay, hole. H-O-L-E, not W-H-O-L-E. Okay, okay. So whole projection area. Okay, and if you compute using your calculator, we can use it. Okay, we can open our calculator and verify. You have to use your calculator even if it is already there, even if the answer is already there. Let us use our calculator. Okay? Calculator. Where's our calculator? Casio. Calculator. Okay? We have the calculator here. Okay? So let us make the calculation for that. So 4.71 minus 2 wholes. 4.71, the unit is already square inches. 4.71 square inches minus 2 times 1 and 1/8. Okay. 1 and 1/8 is 1 plus 1/8. That is 1 and 1/8. Okay. That is equal to 1 and 1/8. Okay. Multiply by 0.22. So, and press equal sign. The answer is 4.215. So, therefore, we found out that the real answer is 4.22. Why? Because of our, the answer of the book is probably correct because of different agreement with the if you read the preface you can maybe able to find out how the author will express the final answer. However, you and I already agreed that we will use 3 significant figures. Okay? I don't know about this author, but we already have agreed that we will express our final answer in 3 significant figures. Okay? When we are computing for the design and analysis. Okay, so like this one, 4 point must be 2 because we are what? We are rounding off the numbers. Okay, rounding off. So 5 will be rounded off, so it will become 0.22. So instead, we found out these things. Okay, so without using the calculator, we cannot find this out. Okay. So next, the next part that is another possibility for failure, that is A, B, C, D, E. So this is another part, A, B, C, D, E. Okay? So A, B, C, D, E. Again, gross area. Okay, another minus, but now, as you can see, there are 3 holes along that path. 1, 2, 3. There are 3 holes along that path compared to only 2 on the other path. Okay, so there are now 3. So multiply this one. But now, since this is staggered holes, we have to add. We have to add what? What we need to add? S squared over 4G. Right? S squared over 4G. Right? And how many S squared over 4G? There are 2 diagonal. 1 and 2. There are 2 of them. 1 and 2. And the distance of this, they are equal. So there are 2 equal. So therefore, we just put 2 because the 2 values are equal. So we just multiply by 2. So S squared, what is S? 2. This is S. Okay, S is 2. So S squared, 2 squared over 4G. Okay, over 4G. G is 3. from C to B. What is the distance from C to B? Vertically, we are looking at the vertical distance. That is 3. We are not looking at the diagonal distance. We are looking at the vertical distance. That is 3. So S squared over G. So S is lateral distance. G is gauge distance. So gauge distance, lateral distance. Okay? Okay? So therefore, 2 squared over 4 times 3. So this is the path from this point to this point. Now, multiply by the thickness so that we can be able to produce the projected area. So thickness. So multiply the thickness so that we have a square inch. So if we can total all of these 3 terms, let's find out how much is the answer. So let us put the 3 because there are 3 holes here. 3 holes. And let us put the plus 2 times S squared over 4G times 2 squared, okay, times thickness. Thickness is 0.22 over 4G divided by 4 divided by 3 because G is 3. And if you press the equal button, what will happen? So this is the answer. The answer is 4.11. So 4.22 versus 4.11. Therefore, which one is the weakest link? Weakest link meaning the smallest area. So the smallest area would present smaller or the smallest resistance to failure. Okay? So we want better resistance to failure. So this one, 4.22 versus 4.11. Therefore, the answer is 4.11. This is the answer, the final answer. Okay? Any question? Any question with regards to this? Okay? Any question? Please remember S squared over 4G. That is our formula for staggered holes. That must be added. Okay? That must be added. Okay? That have to be added to our path, okay, so that we can find out the net areas. Okay, net areas. Okay. Any question? It is very easy to remember, to recall the formula for staggered holes, S squared over 4G, because G is a gauge. G means gauge. Gauge is showing you when we say gauge, it is showing you the size of the element. And the size of the element can be shown by vertical depth. That's why that is the gauge. Vertical depth from hole to hole. Okay, from hole to hole. Okay, that's the vertical distance from hole to hole. Lateral distance, that is horizontal distance, that is S. Okay, so S squared over 4G. Take note of that. Okay. So, meaning we have the final answer 4.11. Okay. So this is our Number 4 example, let us go to the next example. So we have here the example. This example 4 and this current example number 5, we have different elements, okay? So we have W section here right now, example number 5, we have C channel. This is a C channel, and as you will notice, this C channel is actually what? Actually one half of the S section, okay? S section, recall, S section is when the flange part is not having the same thickness all throughout the flange portion. So as you can see, the flange portion doesn't have equal thickness. So the thinnest part is on the edge of the flange, and the thickest part is on the center of the flange. Okay, so it is what? Going smaller as we go to the edge of the flange. Okay, it is one half of the S section. So imagine if you can have a mirror image of C channel here, so going in this orientation. So you can imagine a section which is equal to S type. Okay, this is another important example. We are showing you 3 different drawings, sketch, to show the first letter A, to show the orientation of the holes, where it is located. So there are 4 holes. Okay, there are 4 holes. So this is the actual drawing. So from the top of the flange going to the center of the hole, 3 inches. So center of the hole going to the next gauge distance. The next gauge distance is 9 inches. Okay, it's 9. And another distance is from the center going to the edge of the flange, that is 3 inches. So 3 plus 9 plus 3, that is 15 inches. So that's why this C channel is what we call C15. That's why it is called C15. Okay, so this is a C15 type of C channel. C15 by 33.9. So 33.9 meaning 33.9 pounds per foot. Okay, and we have a given gross area. This gross area is 10 square inches, which we can also find out if we use table. You have to use table in order for you to confirm. Okay, because there might be some discrepancy. Just like when we are using calculator, there are discrepancy. The discrepancy may happen, so you have to confirm it, how the author decides on rounding up or not rounding up. Okay, so maybe this author is using 4 significant figures and we are using 3 significant figures. Okay, so you have to find this out. Okay, so we have, I can easily show you those table, but we are doing it online, and it is very difficult for me to rearrange my monitor, my screen, just to show a table and go back again. So it's very hard for me because I'm not very well versed in online apps and tools. Okay. So you have to do it. You have to prepare your own table, AIC code, and textbook while we are doing it online. Okay. So we are being asked in this problem to find the net area along the route A, B, C, D, E, F. So A, B, C, D, E, F. Okay? We are just being asked what is the net area along that path. We are not being asked what is the net area of this cross section, of this section. Okay? Because if that is the answer, how many paths this section will have? Okay? How many paths? A, B, D. So A, B, D, and maybe we can call this G. Okay? A, B, D, G. So straight line. This straight vertical line. One path. The next one, A, B, C, D, E, F. Okay? The next one, the third one, listen, third one, A, B, C, D, and G. Okay? Take note of that. A, B, C, D, and G. Okay? We can call this point G. Okay? We call this point G. Okay? So, there are 3. Number 4. A, B, D, E, F. So, there are 4 possibilities. We have to compare all the 4. So, what is your assignment? Your assignment is find out those other path, the computation for other path. This problem is only for path A, B, C, D, E, F. So in this video, your comment on this video should be what are the net area for the other 3 possible paths. Okay, so and let us proceed, okay, to the next figure. I would like to explain. It is very critical for you to understand. We were given a 3/4 inch bolt. Okay, we were given a 3/4 inch bolt. If you are given a 3/4 inch bolt plus, you have to add what? You have to add 1/8. Let us use our calculator again. Okay. Let's use our calculator. 3/4 plus 1/8. We have to find out 3/4 plus 1/8. If you are using mm, 1/8 is equal to 3.2 mm. Take note, 3.2 mm. 1/16 is equal to 1.6 mm. Okay. Take note that on your notebook. Okay. So 7/8. The hole diameter is 7/8. Even if the bolt diameter is only 3/4. So 3/4 is 0.75. Okay. The hole diameter is 0.88 or 0.875. 0.875 versus 0.75. Okay. Note. Okay. So let us remove first the calculator and let us bring the second drawing. So we have the let's go back to figure na letter A. This is the actual. So we have the dimension. We have the location of these holes. But we have holes on the flange. We have holes on the flange. I forgot to mention. There are holes on the flange. At the top and at the bottom. Okay? The bottom and the top flange have holes. And those holes are not in line. This is the top hole. This is the bottom hole of the flange. They are not aligned. They are not aligned. This hole C and D are the holes for the web. Holes B and E are the holes for the flange, and they are not aligned. The holes on the web and the holes on the flange are not aligned. Okay? So, which means we are encountering a staggered hole design. This is a staggered hole design. So, what is the distance from the edge of the web to the center of the hole? So 2 inches. And the center of the hole to the edge of the flange, 1.4 inch. 1.4 inches and 2 inches. So the same from top and bottom flange. The distances. Okay? Only that they are not aligned. However, the correct drawing is like this. This is the correct way of drawing it. It's the correct way of drawing it. Even if this is not aligned with this one and this is not also aligned with this one. Okay? This is the correct way of drawing it when you are going to draw the cross-sectional view. Okay? So, another information, we have the thickness. This thickness and this thickness, the thickness of the flange, thickness of the web, they are also available from the table. But since they are already here, I will use it here. But you, having your table at hand, please take a look at the table for the C15 by 33.9. Okay, look it up and you will see the thickness of the flange and the thickness of the web. If you are doing this repeatedly, even if it is tedious enough, it is tedious, but doing it repeatedly, you will be aware and there is a subconscious in yourself that you can use even after you graduate, taking the board exam, and in your future career. Okay? So it will get into your system. Your system will be able to memorize it. Your muscle memory will take care of it. So, very important for you to experience using table. Take a look at the table. I am repeatedly begging you to do it. Take a look at the table. Okay? That is part of the practice. That is the physical part of the practice. Okay? Okay. So, since we already have this whole lot of information, okay, and we started the discussion with the plate, okay, with a plate in mind, and we use the W section on the previous example, although there is no holes on the flange. But now the difference is from the starting point of talking this net area from the plate to W section, and now the W section is included as the space for holes and bolts. Okay? is now on space. So, because of that, we can estimate this drawing B is an estimate of this S section. Take note. If we are given W section, it is much simpler. Because usually W section, there are times that the thickness of the web is equal to the thickness of the flange. And therefore, it is easier for W section to be represented by a straight plate. Straight steel plate like this. We want to model the C channel as the equivalent of this steel plate. Okay? However, since the thickness of the web and the thickness of the flange is not the same, they are not the same. The thickness of the flange and the thickness of the web, they are not the same. 0.65 is way thicker than 0.4. Web is only 0.4. Okay, this is 0.65. So that's why this is 0.4 and this is 0.65. As you can see, the flange portion is way thicker than the web portion. Okay? Okay. So what we did is to straighten up. So turn this 90 degrees up and turn the bottom flange 90 degrees down. That's why it looks like this. So this section looks like this. So meaning to say, from this center to this center, these are 9 inches. So from this to this, 9 inches. Okay? Okay? However, from this point to this center of the hole, we have to calculate. We have to calculate. How? How to calculate? Take note. How to calculate? We will show on the diagram letter C. So take note of this. This only cares the thickness. This shows us the thickness. But what about the distance? The distance is, let's take a look. From the edge, so this is the edge of the flange, here, going to the center of the hole, that is 1.4 inch. 1.4 inches. Okay? From the edge to the center of the hole, 1.4. So that is correct. So from the edge to the center, that is 1.4 inches. Okay? Okay? The same is true on the other side. On the bottom flange, 1.4 inches. And we already know there is no changes from these web holes. The gauge distance from these web holes is still 9 because there is no changes in the web. However, from this web to the flange, the distance will change. Right? It is not equal to 3 plus 2, which is 5, but it is equal to 3 plus 2 minus 0.4. Okay? 3 plus 2 minus 4. Take note of this. We are using this in actual. Okay? We are doing this in actual. For example, we are bending metal and we are going to install a metal plate that we will bend into C channel. We will compute it like this. Okay? We will compute it like this. Take note of the computation. 3 plus 2. It is logical because we have 3 plus 2, but now we have to subtract 0.4. What is 0.4? That is the thickness of the web. Are we clear? Are we clear? That is how it is being done in real engineering works. But that is not actually mathematically 100% accurate. This is just an estimate. Take note. And this estimate is still what we are using up to this day. Meaning, there are no engineers that discovered a better way to estimate this one. Okay? So, it is another chance for you. Another chance for you to discover something. I give you the hint. You can discover it if you want. Can you find a better estimate than this one? Okay? Can you do it? Can you find it? Better way. So, 3 plus 2 minus 0.4. So, meaning, center to the edge, another edge to center, that is 3 plus 2, minus the thickness of the wave. And that is equal to 4.6. Very important part of this example. Because if you will have the mistake in computing this, therefore you will have a mistake in computing the staggered hole formula. Staggered hole formula, remember, S squared over 4G. Okay? This is G. This is the value of G, 4.6. So 4.6 is very far from 5 because 3 plus 2 is 5. So 4.6. It's very different from 5. Okay? Okay? Are we clear? Can we follow? Can we follow? A very important part. So if this is 4.6, it is the same on the other side. Okay? This is very important. It's very important. So that's why it is very important to sketch the only given here. If this is a real problem solving, I will only give here this first figure. And in the board exam, it is only given. They will only give the figure letter A. You have to do this and you have to do this. Note, it depends on the Board of Examiner. If the Board of Civil Engineers will decide that this problem belongs to the hardest type of problem because they are having a quota on their exam. So there are 100 questions and there are about 23 hard questions. Out of 100, there are about 23 hard questions. There are about 56 easy questions. So 56 plus 23, that is 79. Okay, so 21 average question. Okay, so that is, I think. Oh, it is reversed. So 21 is the hardest question, 23 is the average, and 56 is the easy. Easy, average, difficult. Difficult question, there are about 21 items. 21 items. So, if they count it on the hard question, okay, they will just give you this figure. If they count this into average question, they will give these two figures, A and B. If they will count this into the easy question, they will give you all these figures. This is now easy question. Okay? However, we divided all the time, divide by 100 items. So that's why it amounts to about what? 3 minutes, okay? Or 2.5 minutes. 2.5 minutes to 3 minutes per question, including all the easy question. So, on the easy question, you should be able to save time and then gain time on the easy question, and then use all of the time on the hard question. Okay, that's how you do it on board exam. Okay. Uh, there are specific number of hard question, average question, and easy question. Now, let us go to the solution. How could we solve this? Therefore, it's now very easy because we already know the gauge distance and we already know the lateral distance. So, S squared. So, S is 3 and G, there are two different values, either 4.6 or 9, because this diagonal, this is 9. The gauge distance is 9. The gauge distance is 4.6. The gauge distance is 4.6, 9, and 4.6. Okay, so let us move on to the solution. Okay, solution. So 7/8, again, this is what we found out on our calculator when we determine the hole diameter. So we already know that. So 10, what is 10? 10 square inch. That is the area we get from the table. Okay? Minus 2. There are 2 holes. Okay? With this distance. So there are 2 holes with this distance and another 2 holes with this. This is thickness. Okay? This is thickness. Thickness, thickness. Thickness of the flange. Thickness of the web. Take note. Take note. Thickness of the web. Thickness of the flange. So there are 2 holes in the flange. Okay? Top and bottom flange. And there are 2 holes in the web with this thickness. So therefore, there are total of 4 holes. Okay? Using different and appropriate corresponding thickness. Okay? Now, for staggered holes, okay, for staggered holes, we have this. This is the distance, 9 gauge distance. 9 gauge distance, 9 inches. 9 inches gauge distance. That is the distance from point C to D. That is the distance from point C to D. Okay, here. From point C to D, that is 9. So, 9, okay. So, S squared is 3 divided by 4G, which is 4, 9, times the thickness. Web thickness is 4. So, this staggered hole is in the web portion. Now, another important thing here. Okay? Another important. There are 2 staggered holes. So there are actually 3 staggered holes. I already shown you the 3 staggered holes. Okay? Already shown you. 1, 2, 3. But this is 4.6. This is 4.6. So we can only multiply by 2. Okay? We can multiply by 2, then 4.6. And then 1. So there are 3 staggered distance. 1, 2, and 3. There are 4 holes. There are 4 holes, but there are 3 staggered distance. 1, 2, 3. Okay? Okay, take note. We already know how to determine the gauge distance. Now, another important thing. The thickness of the flange is 0.65 here, and the thickness of the web is 0.4. How can we find the correct thickness for this staggered distance B to C? Because it started from the flange, which is 0.65 inch in thickness, going to the web, which is 0.4 in thickness. We don't have that same problem when we are computing the staggered distance C to D, because they are both 0.4 inch in diameter, in thickness. How it should be done? How it should be done? This is how it should be done. 2 holes, S squared, 3 squared. Over 4G, 4G is 4.6. So it is taken care of this one. What about the thickness? Take a look at the thickness. The thickness is the average. Okay? Average. That is 0.65 plus 0.4 divided by 2. Average of the thickness of the plants and the thickness of the web. Okay? This is not exact mathematics. Again, another formula which is not exact mathematics, but this is how you solve this. You can have, again. That is the current way how to do it. But if you can do better than this, you have to show. You have to have an evidence. I'm telling you, you can make a name for yourself, right? By researching, or maybe making this as your thesis, researching this. If this is bad enough, and you can claim a better one, okay? A better formula, okay? Because this is not mathematically 100% accurate. So this is just an estimate. Okay? Take a look. Estimate. And if you compute all of this, the answer would be 8.78. Let us verify. Let us take care of that using our calculator. So let's put on our calculator. So let us put our calculator on the other side. Okay. Putting our calculator on the other side. Okay. So let us calculate. This is 10 square inch minus 2 holes, 7/8. Thickness is 0.65. Okay, that is the holes from top and bottom plants, minus another 2 holes from the web, which have the same hole diameter but different thickness. Okay, now we have one staggered distance which have 9-inch gauge distance. So S squared is 3 squared divided or multiplied by thickness, which is 0.4 divided by 4G divided by 4 divided by G, which is 9. Okay, plus there are another 2 staggered distances, so 2 again times 3. S squared is 3. Okay, multiply now by the average of the thickness. Average of the thickness. We are just multiplying with the average of the thickness. Okay, 0.65 plus 0.4. So divided by 2 divided by 4G divided by 4 and divided by G, which is 4.6. Okay, so that's all. If you press the equal button, what would be the result? The result would be 8.78. So for 3 significant figures. So 8.78 square inch. So that is our net area. Okay. Any question? Any question so far? Any question? So there are no questions. Let us see you on the next live live stream. We will do it again immediately after this. We will just take a short break, about 2 minutes to 3 minutes break. Okay, see you on the next live stream. Again, expecting you on the next live stream. This is Dr. AP, preaching engineering for